Good morning, guys. I thought I'd start YouTube. I do quite a bit on Instagram, and it's quite short, like sharp, snappy videos. So I thought I'd do a bit more of a long-handed video. But yeah, I'm Adam. I run Berkshire Gas and Renewables. We're actually going over to Eco Renewables now because we've just rebranded, because that's what we're mainly doing now. It's just renewables. So this job over in Maidenhead, we're actually fitting a Viessman. It's a vitocal 150. It's a 13 kilowatt. This customer came to us. He's a very intelligent guy. He's done all his own heat loss calculations. He's done all the designing of the MVHR system on this house. It's quite an interesting one. He was looking for like the most efficient system money could buy, but there was quite a few non-negotiables. Firstly being, I don't know if you can see this, is this kind of like lean-to extension, but it's made out of single skin glass and wood, and he desperately didn't want to get rid of it. So, you know, we've got a 1970s house. It's actually insulated quite well, but that is like single skin glass and made out of wood, so we've got a huge heat loss from that part of the building. So we've had to account for that with installing the underfloor heating. So we as a business, we would always do the heat loss and work out the watts per square meter in each room and size the underfloor heating appropriately. We wouldn't just put a generic pipe sensor into the ground, because we run all our systems on weather compensation. Much more comfortable way of doing things. But yeah, so let's show you around the system. It's not finished by a long shot yet, but we've had it up and running. So this is the unit. Also, the builder's a little bit messy on this job, so we're trying to keep up with it. But so flame returns. I always really like using, I've asked the Sparky to change this as well, because I don't think the connection in the top of the unit's a very good idea, because we get water ingress. So he said he's going to change it for us. Yeah, I don't like to use the insulated primary pro stuff, because I find it shrinks over time. So I really, even though it's more expensive to put it in trunk in, it's definitely, I think it's a nicer finish as well. I don't think the two pipes look very good around people's houses. So yes, this is the indoor. Same again, not finished. Same again, the Sparky's not finished. So this is what we've got at the moment is the Viessman indoor unit. We've got something called Divcons, so that's a mixed unit, and there's some other stuff which I'll go through with you. Now, one of the non-negotiables that the customer wanted on this job was he wanted underfloor heating upstairs. Now, he's a very tall guy, and the door heights are very low, so we couldn't really put an overlay system in for him, because with the floor finishes that he's wanted, it was going to raise the floor height by about 50 mil, which was too much, so his head was going to start hitting. So we've actually had to go for an inlay chipboard version of it. Now, we get our stuff from our underfloor heating supplies from a company called Theo Heat. So I went through it with the owner, and that is very knowledgeable, like knows his stuff. And we came up with a solution. It is an overlay, but it's actually got a 100 micron foil on it. So it's a bit more expensive, but it's got a better value on it that's going to help achieve the target flow temperatures that we're after. But that being said, downstairs we're going to really try and get it as low as possible, but what that means is we're going to have to put something called mixed circuits in, so we're going to have to run upstairs and downstairs at different temperatures, and that's why we've had to put these in. Now, with heat pump systems, me being, I was a heat geek until they sort of made us all pay, but the way of doing things is actually running everything open circuit. A lot of people like to call it open loop, but I call it open circuit. Just the way that a heating system should be designed, you know, it should all come up at the same temperature, and should all fall at the same temperature. And the way that we normally achieve the best SCOPs on heat pumps is by having an open loop system that's designed correctly, the correct pipe size and the correct emitters, trying to keep the flow temperature as low as possible. But on this system, we couldn't do it, because he had his non-negotiable. So we've got to run two different circuits. So when you're running two different circuits, you've got to put two different pumps in, and that means that you're going to have to introduce something called hydraulic separation. Now, with heat pumps, the more volume in the system, within reason, the better. Hence why we normally would opt for a buffer and not a low loss header. So you can see that on this job here that we've opted 100 litres. I think the system volume, we were just under with the amount of pipe work that we had. So so we've opted for a fair size buffer as well, just to extend the runtime of the unit, which helps with efficiency as well. So a lot of people are a bit sometimes worried about the wiring and stuff, and to be honest with you, whenever I go over to a new heat pump, I also think to myself, oh God, I've got to relearn all the controls and everything. But this is actually very, very simple how to wire this heat pump up. So with the Viessman vitocal, you have obviously from your rotary switch, rotary isolator, you'd have a 6mm cable. It's actually with Viessman, if it's a 6 kilowatt, I think it might even be up to 9. You can actually have a 2.5, which I thought was quite strange, with 16 amp breaker. But this one requires a 25 amp B-type breaker and 6mm cable. So you run that out. So it's literally one power 240, or obviously if you've got 3-phase. And then there's a communication cable, bus cable. So it's literally just two wires within the cable. It's actually 3 on this one because it's got an earth in, and it's wired back into the indoor unit. So if you wasn't to have the DivCons, literally all you've got is an outdoor sensor that wires back in. Same again, it's not finished yet, underneath here, which is wired into there. And then you'd have a cylinder sensor wired back, and then all of the controls are off the front of here. At the moment, this is just showing the overview of the refrigeration circuit, so we can see obviously our litres per minute, everything else. But if you start introducing mixed circuits or any other sort of controls, you do actually with Viessman have to put extender boxes in, which are these. Now, although it looks fairly complicated, it's not at all with this. So what we have here is obviously DivCon 1, DivCon 2, whatever you want to call it. You have to select which one you are on these little rotary switches here. But all you've got here is that's power in. Okay, that's power out. Daisy chain to the next unit. Then that's the power for the pump. That's the power for the valve. That's the stat that's on the back of the pipe. And then all you've got here is your bus connections, so one to the next, so daisy chain back to the unit, so they can all communicate. So that's really pretty much an overview of the wiring on it. It's pretty simple. Like, if you've got any questions, just let me know. But a bit more of an overview of what else we've got in here. So obviously, as I said, we've got 100 litre buffer. Really like these pressure vessels. They are so good. Instead of the the crappy red ones that everyone sells, they've got like that really dodgy bracket on the back. Whereas this one is just literally one screw at the top. Comes with this nice valve drain off, so you can do all your maintenance to it nice and easy. So yeah, what else have we got? We fill our systems to VDI 2035, so it's demineralized water. We get all our stuff from Thorough Flush. Check his website, actually, he's got some really good stuff on there. But once we filled the system, demineralized the water, if the customer ever drains down, or sometimes the pressure gets low, needs to top up, that ensures that we're not putting horrible water back into the system. So that is definitely worth having. What else have we got? Secondary return pump for the hot water. Now, on heat pump systems, they are literally the worst thing because they deplete the hot water so much. And obviously we're relying off hot water priority. So if you are running that constantly, it's going to deplete the cylinder. It's always going to want to be clicking back into hot water, which obviously isn't good and it's not efficient. So what we have done with this, it's not wired in yet, but I've requested for the electricians to put PIRs in the bathrooms furthest away from the house, all right, from the cylinder. So when the customer actually walks into the bathroom, it should fire that pump, put hot water up there when it's required, so it's instant out of the tap, and then when they walk out, obviously it's going to turn off. So minimal usage. I think I came up with that idea, so that's one of my special ones. What else have we got in here? Automatic air vents. I think that they are one of the worst things that were ever invented. Excellent for commissioning purposes, but what happens is people leave them open. So not only do they allow air out, they allow air back in as well. So yeah, if you ever got them on your system, make sure that they are shut. All right. I've installed a couple of little nice gauges on it, so we can check deltas and stuff, make sure it's working. Easy hand. What else have we got? Dual cylinder. Excellent pieces of kit. My God, they are heavy, but they are. I think they're probably one of the best quality cylinders on the market. What else have we got in here? Another manifold for downstairs. This vessel. I've had a bit of I put some bits up on Instagram. It's a bit of a wind up. I know it's a bit of a dead leg on there, but it's the only place we could obviously fit it. So that's where that is. We can't really do much with that. What else? The customer is quite into his water quality, so he's got a obviously a sediment filter here, He hasn't actually got the bracket for us, it's hanging at the minute, so we're waiting for that. But now we're starting to look into more filtration systems. I had a customer down the road actually from here in Maidenhead. He had this water checked because his daughter was actually experiencing some skin problems, and it had like 3 times the amount of chlorine in it than it should. So I do try to offer some filtration stuff to my customers as well. But yeah, the overview of the system is sort of there. Yeah, what else have we got as well? The customer's got one of these Sonic, so it's basically just a remote stop tap. So and it detects leaks apparently, so we're putting that in. Water softener's going in as well, so we've still got quite a bit to do. Also, we've got MVHR going in. This customer on this house actually did all the calculations himself, passed them to us. This is what we want, so we're fitting a Zender in here, so I'll do another video for that. But yeah, if you've got any questions on the Viessman stuff, like, I think it's definitely the best quality, well, one of the best qualities out there. I've got 3 that I normally offer my customers. My starting range is normally a Grant Arona, the R290 units. I think they are incredibly well priced, and they're half decent unit. They're pretty quiet. Yeah, I would recommend it. I would probably have one in my house, I wouldn't mind. The second unit that I really love, and I think are very all-rounded, I would call it the BMW of the heat pump world, is the Valiants, the Aerotherm Pluses. And then yeah, like my premium unit that I would always go to is a Viessman. I think, you know, the quality, if you open them up on the inside, the compressor, the way that everything's built, the way it works, yeah, I personally think that's one of the best on the market. So yeah, any questions on this, just let me know. But hopefully you enjoyed my first YouTube video. I'm going to try and do as many as I can. Yeah, if you've got any questions, technical stuff, like, let me know. I've been doing this a long time, so yeah, hopefully it helps with the decision on what you're, you know, what if you're picking a heat pump or something along them lines. So cheers, guys.